Hi, I'm Rich with Inside HPC. We're here at SC17 in Denver, Colorado. And this afternoon, we are at the Comanche Collaboration for Advanced Technology booth. And I've got a number of people here who have been involved in the project. And we're going to start with you, Rick Stevens. Rick, you're from Argonne. What's your perspective? What does ARM have to do with HPC? Why is this important?
Well, I think we're interested in understanding all the ways in which we can advance high-performance computing, and having multiple architectures gives us many more options, having more people able to collaborate to explore the possibilities of where HPC can go. Bringing ARM into the mix is something that a lot of people have wanted to do for a long time, to get chips that are performant and are competitive with the rest of the existing players in HPC. So this gives us an opportunity to evaluate the technology, collaborate with HP and with Cavium, and to really move things forward.
Cool. Well, thank you, Rick. Next question is for Trent. Trent, yes, hi, come on over. I want to ask you about the software stack and the readiness. Can you comment on that?
Yes, so the TOS software stack has about 4,000 packages in it. Most of those are coming from Red Hat and Apple, but we have about 200 that we had to build ourselves. What we did is we used Koji for a build farm, and we were able to just ask Koji to take everything it had built for x86-64 and rebuild for ARM, and it turned out that almost everything built.
Can I ask you about the workload? For the trial, isn't this is like the day job, real bread and butter kind of thing? It's not the cutting edge research kind of work, is it?
Actually, I think some of it could be cutting edge workload, but it is our workhorse OS.
So Nick, can you tell me about what is Project Comanche? What is this all about?
So basically, HP has had kind of forays into the ARM ecosystem before with Project Moonshot and things like that. And really, some of the times we ended up building product and building a product for a software ecosystem that was not ready. And as we saw the new chips coming in, as we saw the new platform coming in, we said, when that thing goes to product to be generally available, the community needs to have a software stack that's healthy, that's ready to go, so that people like all of these guys and all of the HPC community can actually run off the get-go, and that was very important for us. And Comanche, so we set up the Comanche collaboration. It's an open collaboration. We set up a GitHub and mailing list where everybody's coming in. We've contributed software patches, firmware fixes. All of these guys coming in also had deliverables, whether if it was for file systems or runtime enablement. Everybody pitched in so that by now we have a level of, I don't want to say maturity, but it's more mature than if we would not have done the collaboration. And we're really happy because that allows not only us, but everybody building ARM platforms to have access to that diversity and being able to run their codes on it.
So can I ask you about the rack and what's in it? It's a development platform, right?
So basically, it's kind of a standard dual socket system. The processor does support 8 channels of memory per socket, so that does provide more memory bandwidth. So in itself, that's nice. And then the Comanche platform that's transitioning into a product at HP later on in 2018 is really kind of a no-frills platform. It's really a true enablement platform for ARM, for the ARM ecosystem. And for us, it's really all about the software stack, having something that's open and that everybody can contribute to.
So Sai, I understand that your work is really focused around performance and optimization. Yep. How is that working here with Comanche?
Well, it's early days for our performance evaluation, and we've been looking at multiple generations of the silicon. It's getting better every time. We're working with different compiler teams at ARM and with open source compilers, and we're seeing some improvements in all of that too. So we're still bringing up our applications, and we want to be back here, talk about that next year, but things are looking pretty promising right now.
So Chris, please step up here. I got a question for you. You're both a Comanche partner and a Comanche site. How does that work?
So ARM have been very interested in bringing up the whole software ecosystem, so open source compilers, getting all the HPC apps as compiled up as possible, working nice and functionally. But we also have our commercial tools that we're interested in getting built up. So we've got the ARM Linear Studio, compiler, performance libraries, as well as the former Linear products, ARM Map, ARM DDT, ARM Performance Reports. So the full story from profiling, debugging, compilation, all to get high performance. On the other side of things, we're interested in actually getting real workloads working. So on the ARM on ARM side of things, we're doing lots of work in terms of getting real EDA code working. So we've been working with some of the Cadence digital verification software to get that all working. And we also do lots of work on testing out to the full cloud stack.
So Ross, a question for you. I understand you have some experience with this on the software side, especially when it comes to things like Lustre. Can you tell us about your experience?
Well, so yeah, we at Oak Ridge have been working with an ARM platform for a little over a year now, and some of these other people have been doing it for much longer. But as far as Lustre goes, we are quite experienced with Lustre, and we are very much committed to making sure the Lustre client on ARM is fully working and fully supported and ready for production. So that's important to us. So that's what we're going to try and do.
So Rick, I guess a wrap-up question for you. Here we got all these people involved in this collaboration. What do you think is driving that?
Well, the National Labs are extremely committed to pushing forward the boundaries of high-performance computing in this country and around the world. And this project represents a new opening into that ecosystem and gives us new opportunities to explore what's possible. And we all work together on this all the time. It's not the first time the labs are collaborating. We have great partnerships with HP and with the team from ARM. So I think we're very excited about this, and we're looking forward to collaborating and bringing this new capability to the market.